Okay, it's a pleasure for me to be here and to learn about the community, about your requirements. So ABC is doing storage since almost 20 years. I would like to share some of our experience and also ideas how to do storage and what's interesting in the storage area. So let's quickly look at some new technologies. We have now the power of SSD, and there are different SSD flavors around, and what we have seen, we use them now for 1.5 years. It's not a problem of reliability. It probably depends which flavor you take. This is an enterprise product, and currently we use this version, and we also see excellent results. So next generation, you see, it's quite impressive having just on one board 2.5 million IOPS, 7 GB of throughput. And besides this, you see the drives are not as important in our opinion, because the drives, they will always sit behind a rate controller, and the rate controller will break down the technology. So if you would like to profit by SSD technology, we think it's mandatory to go with the PCIe bus directly, because it's at least 4 times faster than this implementation. So this is a very powerful new technology. Since the power of InfiniBand, I think you know well enough. What we have done, we said, okay, we call this a data drone. Why? In order to give you a picture of speed, like a particular accelerator it should be. And it addresses the need, the replication in the storage area, for mirroring, storage server, and what many switch vendors call the east-west traffic, or west-east traffic. And we created this expression or term, data drone, just to give the picture of high-speed connectivity. Another new technology is linear type file system. Is opening up new area of tape. We think it's a revival of tape technology, and you can use in a very transparent way LTO5 and LTO6 cartridges. They are partitioned into index and data, and you can use such media the similar way you are using a memory stick. So data is transparent. You don't need a file server or a backup server installed, which makes your backup readable again, so you just use it. This was developed by IBM, but has become an open standard. There are different editions. So there's a single drive edition, a library edition, an enterprise edition that integrates with GPFS, and there are different operating systems where you can run the management software to manage this. The 2 main players, what we see, there is obviously IBM, who has done a lot of development, invention, and IBM, however, they have the library and enterprise edition with the restriction you have to use an IBM library. And you cannot go to a customer and say, before you use the technology, change the library. Therefore, Crossroads is a very good solution, because Crossroads uses single drive edition with any library. So you see, we are not just proposing one technology, we look to optimize the solution who has best offering for your purposes. Now you say, okay, now we are done with new technologies, but there is a big problem always with new things. And we say, okay, there's another ABC of IT cycles, as you know. So there's a new technology, a hype, we apply it, then we see we cannot solve all the problems. There's a backlog that requires add-ons. as many add-ons until the solution collapses due to high complexity. And then the next cycle restarts again. And the problem is just not to run into this cycle. And you know, probably our industry knows the expression true technology. Now we can guess whether we will ever see a true Facebook or not. That's a discussion maybe. But then we use this ABC approach, try to focus to achieve 80% of benefit just with the 20% of cost. It's very difficult, but it's an important goal in order not to get lost. In addition, one has to be cautious because you know from the Gartner studies, if you buy new technology, the investment is just 20%. And this is important in order to have a look at the solution design, because each layer you will add here means you increase the complexity of your solution by a counter of 5, and not only be 1. And this is important to keep in mind when you say, okay, so I have another server, I have another software package. It's not just a 1 counter, it's a counter of 5. So in order to bring some systematics in all this storage stuff, we have been publishing in 2000 a booklet. This was based on the product of SSA, Serial Storage Architecture of IBM. But we have done an approach how to deal with this stuff, and we have put the storage top of the pyramid because this is the most precious part of your infrastructure. It keeps your intellectual properties, assets. So if you lose it, you lose everything. If you lose a server, you go to the next corner and get the next server. It's not a problem. But to replace all the storage is really a challenge. There is, okay, we have a look how to build subsystems out of SAN, and we said, okay, the backbone technology is disk and tape technology. This gives us a picture, that's the source, things have to flow. Then connectivity has been in the past mainly fiber channel, iSCSI. Then the services is where the feature battle takes place, so is replication, synchronous, asynchronous, snapshots, dedupe, and so on. And important point more and more is management. So we follow this approach in order to bring some structure into the entire storage and to make it more transparent and comparable. How does it look now? So we have our layers. So the storage we divide in the meantime into archive, backup, cache. Services mainly today acceleration, still replication, sync mirroring for high availability. In the past, this high availability was important for the management. It was the pill that management could sleep calm. In the meantime, it's more and more important, the sync mirror, in order to have the possibility of flexible maintenance windows. So you can take down one arm of your system and the other arm is still alive without any problem. The management is a point, and the connectivity we will see. We have the data drum with the low latency fabric. Besides these aspects of the physical subsystems and functions of a storage system, there's another point to be taken into account. This is enterprise search, because you want to find the things of unstructured data. And just put a Swiss cheese cover over this layer, and then you get what you need. Currently, we just are reflecting the physical layers with archive, backup, and cache. But we also have to keep in mind the importance, keep things simple and stupid. This is a very old foil we used already in '78 when we have been doing dynamic production scheduling, but obviously this is a modernized rebuild because the foil was too old to be reprinted. Only the picture was in the head. So you see, you have unlimited complexity with a poor result instead of just going an easy way, a straight way, with a much better result. So first point, if it comes to data, is what are you doing? How do you classify? And some years ago, we introduced the concept of data pooling, which means classify your data into inactive data, active data. This is a normal usage. It may differ, but tendentially it's this way. And in addition, we make the distinction between unstructured and structured data. And this is the concept on what we base it. And what we tend to do is to eliminate all these different things, and to make a holistic concept. So normally we start and say, okay, we have two locations with those three functions where we may mirror or synchronize or just replicate. Then the next step is to bring this on a single level, not having different repositories, which means we should stop having this permanently digging and transportation of data between isolated repositories. That's what we are doing. We have a backup world, we have an archive world, we have a primary storage. So we should use this kind of machine and not having the field full of equipment. Here, probably the manufacturer is very happy and he will write love letters in his hand when you follow this concept as long as possible. But this is not a necessity given by nature. You can break this view of doing things. It's just a question of what to use and how to do it. So the idea is to escape this physically segmented sub-optimization and to arrive here at the logically holistic optimization of the entire storage environment. This is a challenge, and again we have to look not to be too complex. So this is a comparison with the traditional design, where we have a complete zoo of hardware with replication and things like this. Any manufacturer likes this very much, but then when it comes to look at it, we thought, okay, if you have data, you have to archive for documentation or for legal reasons. Why don't you put them immediately on a fast storage system and keeping them for 10 years or how long you need to do it, and just having the active data mirrored, for instance, and on expensive technology. This is the difference, and you see what we try mainly for the unstructured data, we try to remove completely the backup layer for the unstructured data. And why should you backup for 11 years, more or less daily, terabytes of data, instead of having them from the beginning in the right repository? Put it in the archive. How the archive may look is open, whether it's disk or it's tape. Now, this new generation will enable using tape technology, but you can also go, depending on the size, maybe with disk. Now, how to do it? Almost around 2 years ago, there came up the new server generation with PCI Express 3.0. And then we saw, okay, that is excellent products. For instance, this machine with 12 or 24 drives in the front. In the back, we have two 300 or 600 or tera drives for the system. We have onboard 2 times 10 gig, Liquid Ethernet for management, for hosts, and here is reflected that Dell is an OEM for all big software manufacturers, whether it's Google, it's Symantec, or whatsoever, which means you have to facilitate the serviceability of the system. Therefore, you have two SD drives. The technician in the field can replace with the configs, and on the management control you have even an 8 gig SD card. In addition, you can use JBots using the same drives as you have in the server. And now you see one advantage is you are now currently, you end up with a disk price in the server segment and no longer in the storage segment. And you know there's a significant difference for the same price in the server market than you pay in the storage area. But the powerful thing is now suddenly you have maybe 6 PCIe slots, giving you a bandwidth of 64 gigabytes per second. So how expensive or how big must a traditional storage system be in order to get this bandwidth available? Because such a box is around $10,000 maybe. And what can you do now? We put, for instance, PCIe SSD into 2 slots, maybe with 3.2 terabyte. And you do the way coming is you have boxes with a huge amount of SSD already here, and not having them in separate disk subsystems, just as SSD drives behind a RAID controller with a lot of cabling and with a lot of parallel interfaces, bringing the performance back to the, so it's already here included. Then you can add another RAID controller. We have seen with this LSI Mega RAID controller, we can achieve up to 3 gigabytes per second, which is a RAID controller for a few hundred Swiss francs. This is still, currently is still PCI 2 only. So in the next generation, we will get much more power on these standard RAID controllers. And in addition, there's now a new system coming from Dell where you have already 2 redundant RAID controllers in such a system. Because currently this is a system with in the kind of a shared nothing cluster. So you have also solved this problem. And then the fine thing is we put now, just for storage purpose, we use GPFS, and now we can make a direct mirroring between a second system just using the Mellanox VPI boards. And you see, finally, we have adequate speed. Because how would you like to replicate SSD technology when you have them in a prison, like a disk subsystem behind the RAID controller? How will you free up the power of this technology? And we mirror it with GPFS, also over distance. There's now a possibility of a few kilometers already. And then you have two stacks or more stacks, and you have all the possibilities to build up your blocks you need. Then you have maybe reserve slots. You can put another PCI SSD, RAID controllers, or VPI adapters of Mellanox. So how looks now the layer model? Finally, we have a single unified hardware system that fits all. We have here the storage cache. We call it cache. The primary storage we call cache. In order to give you the picture, the cache should be always as small as possible. In order to say you already go and shift away data that are not active. You don't need them to have them on the primary storage. Then we have backup and the software-defined storage, just with different things. Then we use the same hardware here. We may use the same systems down with the clients, and most time, okay, you have often PC power CPUs in the switches, whether it's here connectivity, which is fiber channel, or InfiniBand, or Ethernet. So that's the picture of the landscape, and you see, it's simple. Who cannot support a stupid server? It's trivial. So there is no secret. So at least you reduce the complexity of a system by half, because the hardware is really trivial. No more secrets to look at. So then we built around this, on this standard box. We just use different software, and we individualize this machine according to the needs with different software to cover all these functions. So you see, we have highest level of standardization, best investment protection, simple support, and universal utilization. So if you need a more powerful storage, you just replace the server, load the software, and you use the standard server for anything else. We have lowest complexity, lowest costs, lowest risks. That's what we see is really needed in the storage area field, and it's just a question of time until it will come. So when we have a look and compare, we have cool but complex solutions in comparison to a trivial simple box. And you can, what we will see, you can have a scale-out concept, and here you have this complexity, and here you have a simple solution. Now when it comes to the feature battle, you have everything you need, probably more than one can eat. But you have to have it because the competition takes place into this area. But the main function, what we see, is information lifecycle management. Because unless you have information lifecycle management, you cannot have this movement of data between different functions. HSM is truly not the solution. So there's a big insurance company at Zurich. They annually pay millions of penalties because they don't find any longer the data that are in-house. They used HSM, and HSM means the placeholder is an offline file, so it's not backupped, the placeholder. And if you have once a recovery or a restore, then the data may remain in a dark hole. So ELM is one of the most important functions for such a concept in order to shift data from here also into a library using linear type file system in a very transparent way. I took this foil because there's been a discussion we lack about decentralization. With GPF, with advanced file management system, we have the possibility already to go to other ports under single namespace, having a local cache that is always replicated when the line is up. So there's quite a lot of possibilities, more even coming up. And the question is always whether we'll use them or not. Does it make sense? So you have, for instance, this Scout head, which is just a machine without internal storage, maybe with PCIe, and you put in a fiber channel connectors, and you have your existing system connected. But the strong thing now is we can just scale out. We can add additional heads with or without storage. So we can go this way up. We can scale in. We put PCIe SSD into the box. We can add a JBOD and build one stack of 8.8 petabyte of data. Probably not very useful because the hardware is too inexpensive in order to make such a big stack, because then you buy another CPU which is maybe $3,000 more than just the JBot. And then you have also the excellent possibility to scale up, because then you take over all your existing systems as long as you would like, and this is just acting as a head. So you have complete integration with all those environments. So often when we see during concept presentations, we go back and ask the client, please put really some simple questions. I didn't want to call it the little red hat. So I took the translation from the dictionary and really asked simple questions. So why do we need so many spindles? Why do you provide so many disk shelves? Then you get a true answer that you won't be called anymore for the next 5 years. But this has not been the topic or the focus of what you would want it to do. So again, keep it simple and stupid, and take into account, now there's a paradigm shift. We have excellent standard new hardware. And why should I go with this concept, having 4,000 disks, when you can do it just with one PCIe SSD? To finish, I have an example of an application. Here we have built a 6-node cluster. Each storage system on the GPFS comes with 2 PCIe SSD, because then you can stripe, you can even get more power out of it. And what we have seen in the environment, it's more than 30,000 IOPS per node, and having just one RAID controller is 3 gigabyte. And now what do you guess? What's worth such a node? What would you pay for this performance? What do you think? Single node.
5 million.
5?
Yeah.
Okay, it's $25,000 around,
Okay.
including GPFS, everything, and you just take 2 or more of them, and everything is running. So in here we have built a data drone with the InfiniBand features from Mellanox, and then, since it's hardly cost sensitive to put more or less interface into it, we put here 2 VPI cards. Then, depending on the environment down here, whether you have support with InfiniBand over IPs, and you may go with 40 gig Ethernet and so on. It just depends. But it's really not cost sensitive, because another adapter is a small portion of it. And you see here, with InfiniBand, we do, in any way, we always do a storage replication, the sync mirror. And going with a low latency data drone, we have adequate technology to mirror PCIe SSD. If you wouldn't have this, I don't know, I'm wondering how you would do it with 10 lines or 50 cables or things like this. Anyway, you have always a longer way when you're not sitting directly on the PCIe bus. Then here we have the next aspect to server storage communication, and more in a virtualized environment, in a commercial environment, or you have also in the HPC environment, if the server-server communication, you can organize also through the data drone. So that's an example, and this is to tune an existing VDI environment with 1,000 users. And now we have so much performance reserve, it's probably for some years it's fine. And now they can make all the provisioning of the clients during the day, no longer over the weekend, because you didn't have the bandwidth. And then we saw also the important thing of management. So management is not just to register things. The next step of management is to evaluate all the messages you get, because it's not difficult to get 1,000 messages per day, but the problem is how to evaluate, and when do you have really to get up and jump to the customer, and in which situations can you say, okay, it's good to know, because it's a high available situation, and then you say, okay, it's not, this is a proof of concept, it's not necessary to be there in the next minute. And however, what we see is you need a management tool that qualifies. And we use here, as a kernel, we use Xenos, and we have done all the plugins for the components here with Python scripts. So we know exactly how to check the rate controller of the Dell controller, what is the messages we get from GPFS, and so on. So that's the picture how a high-performance storage solution can look like. Okay, that's it from my point. I would like to draw your attention. There is a GPFS expert workshop, May 6 and 7 at IBM Mainz. And Stefano told me there's another one in London on April 29. So when you send me an email, we will provide you the information so that you can participate and won't miss such interesting input events. Okay, thanks.
Any questions for Alexander? Okay.
Could you please go back in one slide where you show the SSD cards? And you asked the question. Yes, here. So why to buy 4,000 disks where we can do that with a single? So what do you do for reliability and in case of failure of these cards, since they are sitting in one machine?
Yes. Okay. What we are doing is one point. We take the OSZ, which is now a Toshiba brand company, and there's a big difference between the provider of these cards, because OSZ bought before Zenrad, and Zenrad is extremely well experienced in the storage area. So they have done these virtualization appliances for 10 or 15 years. They wrote iSCSI drivers for almost everyone. So this is once the background. Then we take here an enterprise flavor board, which means I have drive recovery, automatic. I have also protection against data loss. And in addition, we have a very granular management telling us how big is the size of, how many bad blocks do we have, and how big or how develops the repository of spare blocks. You can monitor and you know, okay, now this is going into a bad mood. We have such systems now in production since 1.5 years, and we have not seen any degradation of bad blocks or things like this. But now the question is how to come to this high availability. And the high availability we doing the mirror with GPFS. As I have been showing on one of the, here, yes. We have, between the storage systems, we have a so-called shared nothing cluster. So we put here a fat pipe with the VPI adapters of Mellanox, and then we make a sync mirror of the PCIe SSD. And this is mandatory because then you have an adequate speed and technology. And just running through the PCI bus, we get out at least 4 times more throughput and power than with the drives. We don't recommend drives. What drives you can have, but drives are always sitting behind the rate controller, and the rate controller is slowing down, breaking, and prisoning the entire technology.
There's one question about you show us an AFM implementation. Do you have any production system with AFM?
Not yet. Not yet, but it's scheduled because it's extremely powerful and it's an obvious need. It's more a need than to have SIM provisioning and all this kind of stuff and dedupe. Also, when it comes to dedupe, one has to be careful. We will see dedupe on a file level base, which we think is reasonable. But if you do dedupe, for instance, in a storage system on a bit level, bit or byte level, then you no longer have a digital original of your data, which is obviously in no way compliant with least requirements. So one has to be careful. But this is a powerful tool and concept because most companies are in any way distributed and not everyone can afford to have a fat pipe for a sync mirror. So you need to have the async replication. Also important is that you may have on the other side, you may not have a library with LTFS. And then you say, okay, instead of having a backup of all my unstructured data, I shift them directly 2 times on tapes on another side, externally, or once internally and one on another remote location. So there's a tremendous playground with features, and the problem is just not to get lost with dummy features, just to have a look which is a real need, which brings you a good profit, and which just makes the solution more complex and introduces more service layers into the entire system.
Question. Suppose I need 5 times more volume than one box can provide. So how would I do it?
You would just add JBots. You add other RAID controllers on the bus here. And then you add JBots. And the JBots look identically, just to have no CPU board. And you can, to one RAID controller, you can connect 8 JBots of 24 drives, or 12 with 3.5-inch nearline SAS drives, and then you can build up a stack.
But then I need a lot of space, I need a lot of racks.
That's true. We don't have, okay, we could go now with the new version of the 60 drive box. We can also connect, because we can put a SAS controller and just plug it into it. The problem is a little, yes, then you have again the RAID controller in the storage subsystem. You can have it. Future anyway, we see to go without hardware RAID controller in order to facilitate drive rebuilds. So in future we think we will go with the software RAID or the software possibilities GPFS is providing in order to have a workaround for long rebuild times of replaced drives.
This only black box that you have GPFS IBM inside, or it's something that you can connect your real environment and just that this box as a feature that I want to add my GPFS.
Yes, we put on the system, basically we put Linux. Here you see, we put everywhere a Linux here as the first software. Then we put GPFS, and then here for the backup we also put TSM.
So it's not a black box. We can
No. As always, the knowledge is not what you're doing, how you're doing it. So you have to find the way, which is the shortest way. Where can you have some abbreviations? This is experience and comes out of installations. So you can, yes, everyone can do it by his own, and if he has time, to find out best parameter positions. It's time consuming, and this is one point, but the other point is now where is the management? Picking out the serious messages, qualify the message and say, listen, here is a true problem. It's not just, yes, another CRC error or whatsoever. And this comes only out of long time storage experience, because then you have to evaluate what you have seen over those 10 years, what is going to happen, how severe is this message, how severe is this message. And the problem is always this management system. You are buying normally an empty building, and it's up to you to fill up the building. And this is the most hardest thing of any management system. It's not just to have an inventory and to have some nice figures or to have 1 million of messages per day. It's cool, but it doesn't help much. On the contrary, it makes things much more complex.
Thank you, Alexander.